Federal University of Rio de Janeiro, and member of the SILVANUS Project Brazilian team. It's an honor to welcome you all to SILVANUS Project Brazilian meeting. We are delighted to have so many distinguished guests here with us today, including representatives from various sectors of science, technology, and policymaking. This event marks a significant moment in our journey toward advancing sustainable and resilient solutions for the future of our planet. SILVANUS Project, as you know, focuses on the release of a climate-resilient forest management system platform to prevent and suppress wildfires. SILVANUS relies on environmental, technical, and social science experts to support regional and national authorities responsible for wildfire management in their countries. It's a privilege to be part of a gathering that brings together such a diverse group of experts, authorities, and researchers committed to making a difference in these critical areas. Before we begin our discussions and presentations, I would like to extend my gratitude to all the participants, our esteemed speakers, and the team behind the organization of this event for their hard work and dedication in making this meeting possible. We are looking forward to fruitful exchanges, insightful dialogues, and the opportunity to further strengthen the partnerships that will guide our collective progress. At this moment, I would like to invite our presenter, Professor Douglas Knapp, to take the stage and proceed with the official program. Thank you, and I wish us all a productive and inspiring session ahead.
Thank you, Rogério. Good morning. My name is Douglas. I will be one of your hosts throughout this week. So on behalf of the entire organizing committee, I want to welcome you all to this event, and to those who are not from Rio, I want to welcome you also to our wonderful city. I hope you have enjoyed our coffee and treats. It is our pleasure to help you with that, and I see most of you have your gift bags, and that's a good thing because we are talking about the climate here, so not using plastic seems to be the very least thing that we can do. Once again, welcome to the SILVANUS Project Brazilian meeting. We are now about to begin the series of presentations and discussions that will shape this important gathering. I have the pleasure of introducing our first speaker, a leading figure in the field of research and innovation in Brazil. It is my honor to welcome Professor Marisilvia da Costa, Director of Technology and Innovation at COP UFRJ, that's the Federal University of Rio. With a long-standing career in advancing education, technology, and sustainability, Professor Marisilvia has played a key role of scientific research in Brazil. Throughout her career at COP, she has held several coordination positions, eventually reaching the institution's directorate. We are excited to hear her insights on the topics that are central to this meeting. So please join me in welcoming Marisilvia da Costa to the stage. Thank you.
Thank you for the kind introduction. So my name is Marisilvia. I'm Director of Technology and Innovation at COP. I started this position like 2 years ago, and I think my role here at this meeting is to welcome all of you from the most different parts of the world, and here from also Brazil. And wish that you have a very, very pleasant and insightful meeting during these days on a subject that is so important for all of us. When we think about like the past months, when we saw very tragic events related to wildfire worldwide, and when we look at Brazil, and we see that Brazil has a energy matrix that's very clean. It's been like that for a long time. But we see that Brazilian emission is mostly caused by, has a very important percentage that is caused by wildfires in forests. We think that the subject is crucial for we surviving in this planet. And I think the most important is that is not looking at the problem for one only point of view. So we have here at COP. COP is an engineering institute. We have 13 different programs 13 different departments in 13 different engineering that is forming professionals doing research. But when we have a so complex problem, we have to look at from different point of views. So we have to put together the most different areas of knowledge and science and research, and we have to look at the problem as a whole, and we have to work together in order to find solutions and innovative solutions, because we've seen this history of wildfire repeating itself for years and years. So this is the importance of having everybody here. And it's a pleasure for us at COP to receive you, to welcome you. And I'm sure that after these few days of this meeting, we're going to have more projects, more insightful solutions, and a lot of work to implement to bring our planet back to where it should be and avoiding all the wildfires that we've been seeing growing in the past recent years. So that's it. I hope you enjoy, and thank you very much for being here working on this very important subject. Thank you.
Thank you, Professor. Thank you for your inspiring words and valuable contribution to this event. Next, it is with great pleasure that I introduce our keynote speaker for this meeting, someone whose work has had a profound impact on the global understanding of climate change and sustainability. Please join me in welcoming Carlos Nobre, a renowned scientist and expert in climate change and environmental studies. As a former member of the Intergovernmental Panel on Climate Change and a leading figure in Brazil's environmental research community, Carlos Nobre will provide us with invaluable insights into the challenges and opportunities we face in building a sustainable future, particularly concerning the Amazon rainforest. His talk is entitled Climate Future and Amazon Rainforest, Challenges and Solutions for Global Sustainability. Let's give him a warm welcome as he takes the stage. We're facing some technical challenges that are very usual for this kind of event. I hope I can count on your patience, and I'm sure it won't take too long. Meanwhile, I don't know. Eu? Mando o senhor, imagino.
Yeah, good morning to all. I will have to apologize because there are some problems. I prepare my talk. Unfortunately, another excuse, all my slides are in Portuguese. Sorry. But I will, make the presentation in English. Well, needless to say how important we are discussing these issues, and I like the discussions that you're raising here. Needless to say that we are going through the climate emergency in the planet. And in particular, you've seen all climate extremes reach the top extreme ever. Anything, heat waves, rainfall, inundation, floods, droughts, strong winds, but also, as you know, forest fires. Forest fires reached record-breaking in many, many parts of the planet, including in Brazil. As you know, last year we had a record-breaking number of wildfires. However, we have let me start by just giving this big challenge. We had in Brazil last year a record-breaking drought in Brazilian history. 60% of Brazil was under a severe drought, like, record-breaking drought in the Amazon, the second largest drought in tropical savanna, the Cerrado, also droughts in part of southeastern Brazil, et cetera, et cetera. So, of course, when you have a severe drought like that, you don't have much lightning strikes. So when you go to that record-breaking forest fire in Canada, summer 2022 in Northern Hemisphere, there was a record-breaking fire, 1.2 billion tons of carbon dioxide emitted due to that fire. But that was almost all fires were lightning strike ignited fires. In Los Angeles, in January, 0 fires were lightning strike ignited fires. Most of those fires, few fires were considered to be arson. Most of the fires were the record-breaking wind, and then that brought down a lot of transmission lines, and there were, the fires from the electricity on the broken transmission lines. However, in Brazil last year, INPE's studies, Brazil's National Institute of Space Research, INPE, they show last year we had close to 240,000 forest fires, or vegetation fires, not only forests, but 98% were man-made. They were not lightning strike ignited fires. So I can tell you one more big challenge on the issues that you're discussing here, which is, of course, we can reduce a lot, but how to combat the illegality in the fires in Brazil. And also now groups are starting to study, and still we are trying to understand, but in my opinion, more than 50% of those fires in Brazil last year, they were criminal. They were not let's say a cattle rancher using fire and then the fire escapes the pasture and goes into the forest. No, more than 50% is criminal. For instance, INPE's monitoring show more than one third of those fires were in forests. They were not very far from agricultural crops or pastures. So it seems that, unfortunately, the fires and also a number of fires in the Amazon, they were all controlled by organized crime. So I'm just saying a big challenge that we have. I don't know if you, 1 minute. Anyway, I just want to introduce, because really, information platforms. And let me tell you one more challenge for these high-tech integrated technologies. Why it's so difficult? Because currently the system to monitor wildfires is, in Brazil, is through geostationary satellite. This is geostationary 16 satellite. It's geostationary, very, very high. And the satellite detects wildfire only when the area burning is about 30 to 40 square meters. And how long does it take? It takes 1.5 to 2 hours for the fire, for the satellite detecting system to detect the fire. So INPE produces this all the time. And just to finish this initial, so, and of course, for organized crime, setting fires, someone sets the fire. You remember in August, in São Paulo state, the police arrested 15 people working for PCC, the organized crime in São Paulo state. They were being paid by PCC to set fires, mostly on sugarcane plantations. But anyway, so I'm saying this is please, you're talking about technologies. Now we have to find systems that will detect immediately fire, not only 1.5, 2 hours later, as the system is today. So this is a big challenge. Let me, okay, let me see. Para andar qualquer é aqui. Okay, thank you for your patience. I will talk about this climate. Oh, again, as I said, apologies. All my slides are in Portuguese. Sorry. I'll talk about this climate emergency, the challenges we have to face. A little bit I'll talk about, very briefly, about the Amazon as well. Okay. So, briefly, let me just say, IPCC report to 2021-2022 was very clear. We are reaching, at that time, for thousands of years, the record, but now we call climate emergency. It's not only climate change. And really, this climate emergency is because there is no sustainable plan B, because there is no way to get out of our planet. There is no planet B. I was also member of 4 out of the 6 assessment reports IPCC, but the last one is very clear. It's a red warning for humanity. No questions. The IPCC report shows all these climate extremes and the warming is not natural. It's doing by our action. And you see here, all this climate temperature data from 1860 to the present, and you see really from 1970s that very fast increase. Decades ago, 0.18 degrees of per decade. Now, the last decade is 0.26, and I will show the explosion of warming in the last couple of years. And this is just to tell you how the ocean also, record-breaking ocean temperatures, for instance, record-breaking North Atlantic, Western Pacific Ocean, Indian Ocean, and the Southern Ocean near Antarctica. You see there, record-breaking, and this is a big problem because when the oceans become very warm, it's not easy to change. And here, another question. This is Copernicus Institute showing a big change. Why are all these extreme climate events becoming much more frequent in the last 2 years? Look at that. This is the moisture, water vapor, moisture in the atmosphere. So in 2024, 5% more than this average 1991 to 2020. And when you have more water vapor, this is really the energy that we bring. Evaporation of the water, energy, and then condensation, forming the clouds, and that generates all the energy of all meteorological phenomena. So this is really to explain why the temperature also is making much more, the atmosphere having much more energy. Well, as you know, 2024, the record-breaking year, 1.55 degrees warmer than 1850-900, before really the global warming started. And also a big mystery, thousands of scientists are studying. Part of the warming of 2023-24 was directly given to El Nino. You see January 2024, 1.66 warmer, but then January 2025, 1.75. Now we have a La Nina in Pacific, cooling. So thousands of scientists trying to explain what is going on. And I think it's very important for us to answer the question, or science needs to answer the question, whether we are going to have permanently 1.5 degrees or warmer or not, or is this natural? This is not natural. So I just want to tell you, I will say 7 hypotheses that would try to explain, and I'll go quickly. 7 hypotheses why we reach 1.5 degrees. Why do I say that? Because in 2022, we're 1.2 degrees warmer. I'm talking about global. And then El Nino, very well predicted, and then it was predicted 2023 would reach 1.3, and then 2024, not more than that, because El Nino would vanish. And then all of a sudden, second half of 2023, 1.5, and then 2024, 11 months out of 12, more than 1.5, and then almost 1.6. So why is that? So let me go quickly on the 7 hypotheses. What might be explanations, physical explanations for the 1.5 degrees 2024? And one of them is that the clouds overland in 2024, there were less. Of course, low-level clouds, the solar radiation reflection, albedo, is 56%. And when you don't have that, oceans, albedo is 6%, land albedos with vegetation 10 to 20%. So you have much more solar radiation. So I'm just saying, this is hypothesis 1. Hypothesis 2, also low-level clouds all reduce all over the planet to 2024, 2023, and 2024. So this is also a very important element here. Hypothesis number 3, okay, aerosols. Aerosols, these microparticles, mostly from burning coal, oil, diesel, and they have sulfate. And sulfate dioxide is a microparticle that reflects solar radiation. So globally speaking, all these aerosols cool the planet 0.5 degrees. And people say, oh, wonderful, let's keep burning oil. No, because in case you don't know, this is the cause of air pollution. Urban air pollution in the world, mostly caused by this. and 6 to 7 million deaths a year due to air pollution, urban air pollution. So no way to defend the cooling. But I'm just saying, one of the hypotheses now is because particularly China is the country with the largest emissions of greenhouse gas due to fossil fuels. And also, 20 years ago, life expectancy of people in Beijing, it was reducing. Why? Pollution. So they started reducing pollution a lot. People say that, but that does not explain this big warming. As I said, we had 0.4 degrees warming in 4 years, 2022, 2025. Also, of course, as I mentioned, El Nino explains the warming in second half of 2023 and up to April, May 2024, but then no more El Nino, the temperature continued high. Also, in the last couple of years, 3 years, the ships are reducing a lot pollution. That's one more element, but does not explain, of course, this big warming. And also, in volcano, this water deep in the southern Pacific Ocean, in January 2022, so it really released a huge amount of water vapor. Water vapor in the atmosphere goes down very quickly, but a lot of this water vapor reached the stratosphere. Stratosphere is very stable, so the water vapor is a greenhouse gas. But it was gone in 2 years, so it does not explain all this warming, but it may explain part of the warming. And also, never before, look at the January 2024, January 2025, the concentration of carbon dioxide, parts per million. 4 parts per million, never before, in 1 year. And you see there, the table there, in the 1960-70, it was 0.87 parts per million per year. Then 2010, 2023, 2.4, but then in 1 year, 4 parts per million. Then you say, wow, 4 parts per million. No way 4 parts per million would increase the temperature 0.2, 0.3 degrees. So I'm just saying all the 7 hypotheses for you to have an idea what thousands of scientists are looking. Why? Because it's really a big problem if we reach 1.5 degrees now. This is, you may have seen, the newspaper, British newspaper, The Guardian, made interview 380 climate scientists, and you see 77% of those scientists said the temperature will go above 2.5 degrees. So this is what most scientists, almost 0 scientists really said it's going to be less than 1.5 or 1.5. So this is a major concern, a major concern. Why? Because as you may recall, if the temperature reaches 1.5 degrees now, we may reach 2.5 degrees by 2050. And what that might happen, and then I want to talk about the tipping points. The big risk of tipping points if the temperature reaches 2.5 degrees by 2050, which is something like that, it will go, it's irreversible. It will go to another stage you cannot go back. So those are, I'm not going to talk about all the tipping points. There are more than 25 tipping points. You see here temperatures in which the tipping points would be reached. Melting of the Greenland, you see 1.52 degrees. Also coral reefs. The Amazon would be something like 2-3 points tipping points. I will talk about a few of these tipping points for you to understand. This is a study that would say temperature goes 1.5 to 2. You see here the blue. You see there, Greenland ice sheet, West Antarctica, tropical coral reefs would be very close now. But in this study, the Amazon would be only 3 to 4. And I will show you that's unfortunately, no, the Amazon is very close to a tipping point. But anyway, just briefly, just let me tell you, you know, this was the main reason why 196 countries in 2021 COP26, Glasgow, Scotland, why people agree on not letting temperature go beyond 1.5, mostly because science knew that if the temperature goes above 2 degrees, we take the extinction of coral reefs. Coral reefs maintain 25% of oceanic biodiversity. So last year, a lot of the, not only last year, but particularly 2023, 2024, huge area. Australia has the largest coral reefs in the planet, 2,300 kilometers. It was, you know, bleaching a lot, but not only there. This is Alagoas here, along the northeast coast of Brazil. The temperature was above 31 degrees in the ocean. Also, a lot of bleaching of there. And the IPCC 2018 showed if the temperature goes above 2 degrees, it will get to extinction of most coral reefs, almost all. And then that's why countries agree not getting the temperature above 1.5 degrees. Of course, also we have a big risk, another tipping point, which is the permafrost. The permafrost store huge amount of methane. Methane is 30 times more powerful than carbon dioxide, CO2. And that tens of millions of years, it's permafrost. And now it's melting. Siberia, northern Canada, northern Alaska, and it's already releasing. If the temperature exceeds 2 degrees, it will be more than 200 billion tons of these gases. Just is one very dangerous tipping point. And also, as you probably know, in Canada, they even show a lot of virus were frozen there, tens of millions. But there are viruses that don't exist in the planet anymore. So there is also even a risk of epidemics and even pandemics. Also, the Greenland, I'm sorry, I'm not going to joke, but did you hear that President Trump wants the melting of the Greenland? Yeah, he wants the melting of the Greenland because he wants to explore oil, minerals in Greenland. So the Greenland is also rapidly increased, very rapidly the melting. And also, if you go the last interglacial, 1.5 degrees, you have to go 120,000 years ago. And at that time, because of 20,000 years with the temperature between 1.5 and 2, the Greenland had melted a lot. Sea level was 6 meters higher. Just to give you some of this figure, this is also a big risk. And of course, the Antarctic as well. Mostly Western Antarctica is already accelerating the melting a lot. Also, we call Atlantic meridional overturning circulation, which is this circulation that deep the water, you know, in the near Greenland will go down. It comes 3 kilometers depth in the ocean and reaches the Antarctica here with very cold water, maintains the ice sheets there, etc., etc. And then it will go up and then becomes the Gulf Stream, bringing heat to the north. That's why Great Britain and also the northern countries there are not as cold. But anyway, now this AMOC circulation is decreasing. There is a risk of completely being interrupted. And currently, it's making the tropical Atlantic warmer. So this is another tipping point. And of course, I want to highlight a little bit here, the Amazon. I was the first scientist in 1990, 1991. We published 2 articles in Science, Journal of Climate, talking about the risks of the tipping point of the Amazon. At that time, it was mostly deforestation. Because, you know, at that time, when I did this study, 88, 89, we are not talking a lot about climate change. But deforestation was exaggerating a lot in the end of 1980s. So we did this study, but now many studies with former PhD students of mine, we did many studies saying if we had only deforestation, zero global warming, if deforestation exceeds 40%, we go from this to that. Forests only in the Western Amazon near the Andes, because it's a lot of rainfall, 3 meters or more, and then 50 to 70% of the Amazon becomes that right-hand side there, highly degraded, open canopy, highly degraded ecosystem. Or if we had zero deforestation, but the temperature exceeds 4 degrees, exactly what I showed you before, many studies only look at global warming, not the deforestation. But now, also, our studies show if deforestation goes 20, 25%, and global warming 2 to 2.5 degrees, we exceed. We are very close to reaching the tipping point. All of this huge area, southern Amazon, from the Atlantic all the way to Bolivia, 2.3 million square kilometers. The dry season is now 5 weeks lengthier than 1979. It's becoming 1 week longer per decade. So in 2, 3 more decades, the dry season reaches 6 months. 6 months is the climate envelope of the tropical savanna, Cerrado. So I'm just saying how close we are. And the southeastern Amazon, southern Pará state, northern Mato Grosso, my colleague Luciana Gatti at INPE, I'm also co-author, we showed the area, the forest has becoming a carbon source. Carbon source. In the 1990s, the Amazon forest removed, as you know, global forests remove 1/3 of all carbon dioxide that we emit in the atmosphere. The Amazon removed up to 1.5 billion tons of carbon dioxide in the 1990s. Now it's removing much less, and that part I mentioned, southeastern Amazon, the forest has becoming a carbon source, 2, 3 degrees warmer, 20, 30% drier during the dry season, and the tree mortality increased a lot. So that's at the edge of the tipping point of the Amazon. And the Amazon, that's what I'm saying. If we lose 50 to 7% of the Amazon forest, we release more than 250 billion tons of carbon dioxide. So if we lose the permafrost and the Amazon, only those 2 tipping points will make impossible to maintain the temperature at 1.5 degrees. We are going to get 3 to 4 degrees by 2100. I'm just saying the risks. I'm only mentioning here a few tipping points. There are many more. And of course, there is a terrible tipping point. If the Arctic Ocean, deep into the most oceans in the planet, there is methane. And if you warm the Arctic Ocean 3 degrees, it will release a huge amount of methane. By 21, let's say, a little bit like 100 years from now, 150 years from now, the temperature would be 8 to 10 degrees warmer. So, inhabitable planet. I'm just saying the risks that we have. If we reach the tipping point of the Amazon, which might happen in, let's say, by 2050, it may take 30 to 50 years, and then we lose 50 to 70% of the Amazon. Needless to say, in addition to carbon, also the Amazon has the highest biodiversity in the planet. And when we degrade the tropical forests, tremendous risk of epidemics and pandemics. I don't know if any of you is from Fiocruz, but Fiocruz and Evandro Chagas in Belém, Pará, already measure, monitor, and discover 48 zoonoses. Zoonosis is when a virus can become epidemic or pandemic. 48. 2 of these viruses became epidemics. The first time now, 2024, Maiaro fever and Oropush fever. Oropush fever is spread all over Brazil. It looks like dengue. It's an insect that transmits. I'm just saying, in addition to the risks for the climate, also for generating pandemics, epidemics, and pandemics. 2 of these 48 viruses, the transmission is like COVID, human to human. And you know, this is really very important. Studies show if we continue degrading tropical forests, we are going to have 1 to 2 pandemics per decade, like COVID. And also, very important element of the Amazon forest is, also I was the first scientist in 1990. I look at, you know, looking at the water vapor that comes from the Atlantic. It's brought by the trade winds into the Amazon basin. And however, the forest recycles water so efficiently. For instance, the forest recycles 30 to 40% of rainfall in the Amazon depends on recycling. For instance, when you remove the forest we have pasture. Pasture recycles only 1/3 of the water vapor, so much less rainfall, etc., etc. And also, my study there in 1990 showed almost 50% of the water vapor that enters the Amazon comes here. In 2006, myself and colleagues, we gave the name of this water vapor transport flying rivers. And this is a lot, just to give you an idea. The Amazon River discharge is 220,000 cubic meters per second. And the flying rivers is about 200,000 cubic meters per second. And this feeds the rainfall systems in the tropical savanna, Cerrado, southern Brazil. 15% of the water vapor in southeastern, even here, comes from the flying rivers. I'm just saying. And I study a former PhD student of mine, Marina Irota and colleagues, done here at Serra Pilheira Institute. Beautiful study. The study show, you see there the light green areas, this is indigenous territories. And the study only show the water recycle in the indigenous territories, how it supports rainfall. And the blue one is, you see percent-wise, you know, western Amazon, tropical savanna, Cerrado, and southern Brazil. You see up to 20% of the rainfall depends on the flying river, and this is only the rainfall in the indigenous territories. Now they are doing more studies to see all the forests and the importance of doing forest restoration. I'm just saying this is important Amazon service. Let me go now to finding solutions, mitigation, adaptation, big challenge of mitigation. Already I mentioned to you, COP21, the Paris Agreement, 2015 said we should not go above 2 degrees, 70% reductions 2050, net zero 2100. But then COP26, as I mentioned, no more than 1.5, 43% reduction by 2030, and then net zero by 2050. But as I told you, this is a very big challenge, because if we reach 1.5 degrees now, we cannot really do that. We are going to reach 2.5 by 2050. Look at here, all the large-scale emitters of greenhouse gases. US is number 1, 20% of global emissions. The dark color, fossil fuels. Green, land use change, deforestation, and agriculture, livestock also. China second, Russia third, Brazil fourth, Indonesia fifth. But look, Brazil and Indonesia, almost all land use change. And that one is emissions from fossil fuels there. Currently, China is number 1, US is number 2, India, Russia, etc., etc. Those fossil fuels. Brazil is much less. Brazil in 2012 2022 show 75% of emissions from land use change, 50% deforestation, Amazon, and tropical savanna, cerrado, and 25% agricultural and livestock. So really, that's what I'm saying. Key message, let's really maintain the temperature, not much more than 1.5. And if we reach 1.5 now, it's a big challenge, the largest challenge in humanity. So we have to reduce tremendously by 2030, and then it may become almost impossible to keep at 1.5. We have really to reduce very rapidly. And these two studies published a few days ago in Nature Climate Change are very concerning, because they are two studies that show that as soon as we reach 1.5, as we did 2024, it may take a little bit longer, but we are not going to go down. So these studies show that we are very close to reaching 1.5 degrees. Sometimes a little bit more slowly, we are going to reach 1.5 a bit more. Or this one, if we go rapidly, in the next 20 years, we don't go back. It will be 1.5 degrees. So these two studies published a few days ago, I mean, they are really something we have to pay a lot of attention. Whether this all, I showed 7 hypotheses of this 1.5 degrees, but we have really to pay attention whether we are going to go down or not. But if we don't go down, then we have really to be much more ambitious. And I want just to say here initially Brazil, and I want to say why I think Brazil has all the possibilities to be the first country to get net zero. Let me tell you, 2022, we were 11 per capita, 11 tons of CO2 equivalent per inhabitant. This is a lot, because China, 10.5, India, 2, US, 16.5. So I'm saying, so Brazil was not in a good position saying, no, we don't emit. We emit a lot, and also per capita a lot. As I said, 75% 2022, land use change. So let's see, let's reduce 60% by 2030. How? Brazil launched the Plana VEG, restoring a minimum of 12 million hectares, all biomes in Brazil, that will remove a lot of carbon. So, and then Brazil also has this plan of getting to zero deforestation by 2030, as you know. And Minister Marina Silva, she is very brave, because she says not only illegal deforestation, we have to get zero deforestation in all Brazilian biomes, and then large-scale forest restoration. And then, that would be, by 2030, we still would have 1.2 billion tons, but mostly still a transition towards energy, renewable energy, and most of those emissions continue to be agricultural, but that will be zero deforestation. And then, look, I'm talking here 2040. I'm not talking anymore 2050, because if we reach 1.5 degrees now, there is no way. As I said, 2050, 2.5 degrees, ecocide, ecological suicide for the planet. So 2040, is it possible? Yes, of course it's possible. 100% of clean energy, and then negative emissions. So let's remove a lot of carbon dioxide past 2040, a neutral, zero emissions from agriculture, regenerative livestock, and then large-scale forest restoration. Brazil can, by 2040, to have 1 million square kilometers in all biomes restoring. Today we have 3 million square kilometers, cattle ranches, agriculture, silviculture. Let's have 1 million, and then we are going to remove 1 to 1.2 billion tons of carbon per year for more than 40 years. So let me now tell you a little bit about, now, in addition to mitigation, we have to combat firmly for adaptation. Why? Look at this. Floods, droughts, heat waves, extreme rainfall, it's from 1970 always exploded in the world. Very briefly, let me tell you, because we talk a lot about rainfall, floods, inundations, etc. However, this is really the major problem for our humans. The heat waves. Heat waves are, we call a heat wave is called by a high pressure system. This is a meteorological event that happened millions and millions of years. It's a high pressure system, so keeps the air coming down. It warms up, removes the clouds, warms up. This is very common, but now heat waves are becoming much more common. Remember I said the atmosphere has much more energy. So these heat waves, just to give you a few data, this is summer, Europe summer 2022, 62 deaths were caused directly by the heat waves, mostly women and men over elderly people, 80 years old. But of course, this is the World Health Organization says this number is much bigger, because this is what medical doctors will tell. The reason was the heat wave. By and large, they say more than 500,000. And here, just a study in Brazil, 2018. Look at the cities here, including Rio. Almost very little heat waves in 1970. Look at heat waves 2018. This, if we put 2023-24, it explodes, increases tremendously. Record-breaking heat waves in Brazilian cities in the last 2 years. And this is the number, 48,000 people, this study show death due to heat waves. You see here people over 65 years old, it's majority. The green one is percentage of men, and the red one, women. So like in Europe, many more women die of heat waves, and also, of course, this is because women in Brazil also, they have a life expectancy 6 years more than men. You may remember this famous, very traditional Islamic ceremony in Mecca, always in June. This one in June last year, in 2 days, 1,300 people died. Why? Look at the heat wave, almost 52 degrees, desert, etc. So just to tell you the risks, and then just to tell you, look, from 19th century, all the cities in Brazil, you can see compared to the temperature 1961, 2010, 50 years, look, green, blue is a little bit cooler than this average, but look in the last few decades, in the last 20 years, exploded. All the heat waves in Brazilian cities. You can see here in 2024, all the cities with more than 40 degrees heat waves. Here also, the heat waves in all the cities you hear in cities in Brazil, all this above 40 degrees in many, many cities in Brazil, in all of Brazil. And here, just we are in Rio, just for you to see this Guaratiba, 44 degrees, record heat wave as well. This is happening all over the planet, and certainly in Brazil as well. And, in terms of health, why we cannot accept the temperature reaching 3-4 degrees by 2100? This is because the science shows that very well. If the temperature reaches, we use this term, wet bulb temperature. If the temperature reaches more than 35 degrees and the relative humidity, the air is totally saturated, 100% relative humidity, then we cannot lose heat. We cannot transpire. If we cannot transpire and also irradiate heating because the temperature, air temperature is more than our temperature, 35 degrees, babies, small children, less than 5 years old, elderly people survive only half an hour if we are unable to lose heat. This is a biological evolution, important for you to know. A biological evolution, we Homo sapiens, 200, 250,000 years. Our predecessors, Homo erectus, 2 to 3 million years, never the temperature reached this high value that I'm talking about. Never. We never evolved with capacity to lose heat. So the planet becomes inhabitable if we reach to 3, 4 degrees, all equatorial areas inhabitable, and also mid-latitude during summer. If we reach, as I mentioned, 8 to 10 degrees by 2150, only top of the mountains, Arctic and Antarctica, will be habitable. So I'm just saying that we are, and also I mentioned we humans, but of course if we reach 3, 4 degrees, we start the 6th species extinction. The only one caused by a species, we, Homo sapiens. So I'm just saying the risks, and this is just a recent study showing here, 2024, you see here the number of days with heat waves. Look at here, Rio, southeastern Brazil, 30, 40 days they had heat waves. Just to tell you this very much risk. Also, I just want to highlight a little bit here. Of course, all of you here in Rio, you know very well that excessive rainfall, January 2011, in this area here near Rio, in the Serra de Mar, the Petrópolis, Teresópolis, Nova Friburgo, etc. What happened? 4 hours of rainfall, 200 millimeters in 4 hours, created gigantic landslides and also floods. 918 deaths. 918 deaths. The largest. It was a meteorological phenomenon that we call South Atlantic Convergence Zone, in Portuguese, Zona de Convergência do Atlântico Sul, South Atlantic, that created this situation with a lot of rainfall there. And then, and in fact, I mean, I just want historic, I have to say, I was working in the Ministry of Science and Technology, and then after that episode, President Dilma gave me this challenge, which was to create CEMADEN. And because of this episode, we created CEMADEN, that's a Center for Warning. And yeah, you remember that. It's more than 5 million people live in areas like that, you know, areas subject to landslides and floods. And here, just to give you a little bit, we have been seeing record-breaking rainfall episodes since 2021 all over Brazil. We had very famous in May last year in southern Brazil, Rio Grande do Sul, 182 deaths, mostly landslides as well, affected more than 2 million people. And let me tell you, since you want a little bit about fires, let me say those are all the fire photos of fires in Brazil, record-breaking fires. Just to give you this figure is just the January to 14th February. You see the number there. Even during the rainy season, you see a lot of fires, 1,000 fires, several thousand fires. Last year, we had close to 250,000 fires. And unfortunately, as I mentioned before I start showing the slides, before fires were mostly lightning strike ignited fires. Few were man-made. Now, as I said last year, 98% were man-made. Or at least the origin of the fire was man-made, not lightning strikes. And here, just to see the fire last year, this is carbon monoxide. It's very bad for the health, even in Rio. But look at here, you know, all these fires brought a lot of this, and actually some of that reached South Africa. That's the aerosols. This is the reason a lot of diseases and deaths, the pollution from these aerosols, and also, the CO2 showing tremendous amount of CO2. Just this Semaden's study, just to give you, this is for 825 cities in Brazil, 92 million Brazilians. This is based on the census 2010. They are doing now the census 2022, but look, in the southeastern Brazil, here, all southeastern, 4 million people live in areas under the risk of floods, landslides, 10% of the population. And this study also shows 2 million Brazilians cannot live, very high risks. They cannot live there. They have to be removed for adaptation. This is the census with 92 million. Now, Semaden is redoing that with more than 2,000 cities, and I'm sure this number will be more than 4 million people. Well, needless to say, how many of these people live here in Rio, in the state of Rio. So very briefly, let me tell you, adaptation, we have really to move very fast toward adaptation. As I said, we reached 1.5 degrees. People thought if we continue with emissions, we are going to reach 1.5 degrees permanently by 2033, 35. Imagine if we anticipate 10 years. Globally, we are not adapting. In Brazil, almost nothing. As I said, perhaps 4 million Brazilians cannot continue living in areas under the risk of landslides and inundations, floods. So just to give you this big challenge, so some adaptation policies, public transportation, sustainable mobility, resilience, increasing resilience of large-scale resilience. Just to give you one important element, I am a member of Brazil's Development Bank, BNDES advisory board, and we are trying to start the BNDES to fund, to create educational for fundamental school and high school. Like in Japan. Japan is doing education of the children there, fundamental and high school, for more than 70 years, to be prepared. So we want really to start developing educational system, and for sure, university here would be very helpful in helping us to create this, to turn all population more resilient to these climate extremes, and it's important to educate the young population. To remove, as I said, 4 million people from these areas under this risk, and to protect tens of millions of elderly, young people, babies, and people with diseases to the heat waves. And then I will very briefly mention these urban sponges to make Brazilian cities much more resilient to these impacts. This is what we call ecological transformation. Let's really bring back the ecological systems to support, to maintain biodiversity, but also to protect us from the climate extremes. One element here, I already mentioned to you how important it is to restore, to protect and restore, zero deforestation, degradation, fires. Brazilian government has this now, this policies towards sustainability, zero deforestation by 2030, large scale forest restoration, all biomes, and then let's create a new bioeconomy based on the biodiversity products. So this is our big challenge. And let me just say, I mentioned Brazil launched at COP28, the so-called arc of restoration. These are the two arcs of deforestation in red. We have to restore, to save the Amazon forest, not less than 500,000 square kilometers. That will remove 600 million tons of carbon dioxide per year, but also protect biodiversity and prevent the Amazon reaching definitely the tipping point. So let's give scale to this project. And also, I just want to say sustainability for cities. We call sustainable cities. All cities have, and certainly you know, we have the so-called urban heat island. When you have forests, 75% of net radiative energy, mostly solar, is used to evaporation, transpiration. When you don't have, unfortunately, Brazilian cities don't have. Rio is a beautiful example when you go to Floresta da Tijuca, Tijuca Forest. Near Tijuca Forest, much better climate, much better. But most Brazilian cities don't have forests like São Paulo. And then, of course, this radiative energy goes and heat the cement, the asphalt, the concrete, so the temperature becomes much, much warmer. This is a study, unfortunately I don't have this number for Rio, I apologize, but this is the study for all the cities in the São Paulo state. Now, for instance, this is São Paulo city. Look at this. The maximum temperature can be 5.7 to 10.1 warmer than the Atlantic forest nearby. So just this is, and that's why, you know, you've seen the news, all this record-breaking rainfall, wind speed in São Paulo city. Part is because of this heat island effect. Of course, part is this global warming, but it becomes much more extreme. So that's why many cities in the world are making this it's called urban sponge. You restore the vegetation in the cities, near the cities to avoid river floods. This is China is one of the top examples. The greenest city in the world is Singapore, but also China is doing a lot. You see here, beautiful. There are more than 25 cities, big cities in China. Now they are doing this urban sponge. And so that's the concept, really. They occupy only 4%, but 67% of energy used, 70% of emissions of greenhouse gases. So let's create smart cities. We have to accelerate that in Brazil. We have very little of that in Brazil. Let me just very briefly tell you my final comments to you. Well, needless to say, we are concerned with this new president in the U.S. like he did 8 years ago, you remember, 2017, 2020, he also immediately tried to get the U.S. out of the Paris Agreement, now again. But we have COP30 in Belém. Let's make COP30 the most important of the 30 COPs. Why? COP21 Paris Agreement was the most important. COP26 was the most important. Now we have to make this the most important, because COP26 was, let's not exceed 1.5 degrees. Let's take for granted that if we exceed. So we have really to get to net zero emissions by 2040, not 2050. Very rapidly. Why not? Let's make Brazil. Why? Because Brazil, about 20% is emissions from fossil fuels. Let's get to net zero reduction of deforestation. By 2030, we reduce 50% emissions, and then energy transition, and also moving more quickly towards regenerative agriculture, regenerative livestock. It's interesting for the agricultural sector, because regenerative agriculture, regenerative livestock make the agricultural, the crops much more resilient to the climate extremes. Last year, we had a record-breaking drought, a record-breaking fall in the soy crops, and many others. Livestock production, much lower, et cetera, et cetera. So, you know, regenerative agriculture, regenerative livestock is also very important. Also, uses much less area because it's For instance, livestock farming, the regenerative livestock is 2 to 5 times more productive than the average, very low productivity livestock in Brazil, and also is more lucrative. It's not only economically makes sense, but we have to accelerate transition in Brazil. We have to reduce our inequality, socioeconomic, really, because, for instance, only 28% of residents in Brazil have air conditioning, and as heat waves are the main cause of that. So I'm just saying we have to keep really to improve adaptation to these all extremes, protecting population, also protecting our environment and biodiversity, and also protecting even the infrastructure. You see all the problems that exist in infrastructure by these extremes. Fast accelerating public policies for adaptation as well, and increasing resilience of all sectors. As I said, ideally in 2 years we would like to finish this, creating this course for children to be resilient to these all climate extremes. This urban sponge, really a large scale, let's make like, you know, the forest here, parts of the forest Tijuca, etc., as for all cities in Brazil. Very rapid encouragement in creation of policies for faster transition. Brazil is a country with the largest, one of the largest potential of solar, wind, green hydrogen, etc., etc. And also, I'm here in this beautiful, where is here? COP. So you know, COP has made fantastic studies showing the potential of having renewable energy from the ocean, including beautiful calculation, sea level variation in the Amapá. There's 5 meters. At that time, unfortunately, it's no longer with us. Pingelli was the director here. 5, you know, the Amapá ocean variation, its waves is 5 meters. So there's tremendous potential of energy. And also, COP has developed some studies, mathematical modeling, to look at the so-called ocean thermal energy conversion. So this 22, 24 degrees difference between surface and 1,000 meters in the tropical oceans here along the coast of Brazil. So I'm just saying, COP is always leading this transition towards these forms of renewable energy coming from the ocean. Again, Brazil, let's get the first country to get net zero, but also reducing emissions, perhaps more than 50% by 2030. The Brazil with states, cities, communities really have to create a much better future for future generations, and also the new generations have a tremendous responsibility. Young students, please take the leadership that my generation did not do it. My generation was the generation that the science showed the risks of climate change. But emissions increased even last year. So my generation did not find solutions. So you, younger generations, please, and particularly the empowerment of young people and women. So I just want to finish. Thank you very much. I just want to say I'm writing weekly now in the wall, these articles, weekly articles. So, for instance, I wrote one, the heat waves, and then I wrote another one in February as well, the danger of these political policies in the West with the new president. And let me just finish by showing a little bit of this. You'll remember, all of you Brazilians, I don't know for any visitor here, foreigner, if you remember, this is a horse, Caramelo. There was May last year, the record-breaking floods, rainfall floods in Rio Grande do Sul, southernmost states. This horse survived many, many days there. So I think we have to learn a lot. And also, polar bear is under tremendous risk because of melting of ice, sea ice, and also penguins. In Antarctica, 9 species of penguins are at tremendous risk because of the melting ice sheets. But these animals are really trying to survive. They are very good examples for us. Let's really look and learn a lot from the animals. Thank you very much.
Now we have some time for questions, maybe. Anybody in the audience may have a question? We have someone? Okay.
Oh, well, thank you very much for the illuminating presentation from the Brazil perspective. Very, very interesting to hear coming from a different place in the world. I got a couple of questions. Some of them are a bit trivial, so I am going to ask a bit more controversial question related to the expectation. We see this trend is getting worse and worse, and we keep saying by 2050 this is going to happen, by 2100 this is going to happen. And then we realize that we are now in 2025, and what we say that is going to happen in 2040 is happening now. So how realistic are we in these expectations, and how much this contributes to what I see as the most important parameter or factor in the whole equation, which is the sense of urgency. The fact that we just don't care. The fact that we come to these meetings, COP 23, COP 26, come and go, and I have the impression, I am not attending them, but I get the impression that the expectations are being lower than, rather than putting the bar a bit higher. In that context, is not, I don't know, it's not the human condition, the big problem here, and is not really about educating our kids, the new generations. We are too old for that, for adaptation, but educating them in the context of becoming more aware, being aware. It's a problem there. We need to fight this problem. That is what matters. What do you say in that?
Well, that's a good question. You know, you should record that and should bring your question to COP30, because that's exactly what you said is what COP30 has to be the top out of 30 COPs, because exactly what you said. You know, we had unfortunately we cannot say the temperature will go down from 1.5. There is the risk of continuing. So we have to do everything much, much faster now, particularly 4 years with the US going the opposite direction. Yes, we have to do, but technologically, is it possible? Yes, it's possible. Technologically, you know, we can go much faster towards energy transition. As you know, China has shown 2024 emissions were like identical 2023, first time in Chinese history. So we really have to expect China in Belém, in many other countries, including Brazil, etc., European countries as well. They should come and say, yes, we are going to, as I'm saying. Why I'm saying that? Because President Lula, during G20 meeting in November, in Rio, in here, he said, we have to get net zero global emissions by 2040, no longer than 2045. But I am saying 2040. So I'm saying this is really very important. And you're right, I was just talking about educating young children for adaptation. But yes, you have to educate young children to know also the sustainable life requires also getting to zero emissions, etc. This is the idea of the education, but as you're right, we cannot wait until all these educated children will be empowered. That's decades ahead. Really, we have to get COP30 really a big challenge. I'm not going to say it's easy, but let's work hard to do it. And particularly, European Union, please come with because you remember, European Union were the first countries. I do remember, you're from Germany. I do remember, if I'm not mistaken, Germany said they will no longer use coal for energy generation 2035. Norway became absolutely wealthy due to what? Oil and natural gas. They also said zero new exploration by 2035. So European Union has all these goals, very important. So bring also European Union to COP30, and let's say European Union, Brazil, China, India, all get together and net zero by 2040. And also, as you recall, COP29, developing countries were very optimistic. They said $1.3 trillion we need. Nothing was approved. And also, it was approved $300 billion starting in 2026, but U.S. was there. Now, U.S. is no longer. So, but even though also COP30 has to put a lot of, curate this climate, the Green Climate Fund has to reach $1 trillion. Let's be optimistic, at least. I don't know how many of you will be in COP30. I will be there, please. Let's work together, okay?
Any other questions, perhaps? Someone?
First, thank you for your presentation. I really appreciate. And I really appreciated that the person that works in the subject is still hopeful. That makes us hopeful too. My question is not exactly a question, but I would like to have you to comment on a subject that is Brazil has to do ecological restoration in large scale in order to achieve our neutral carbon emission. But I am a botanist, and because of that, I know that plants takes a long time to become forests, which means that if you want to go through 2040 with large-scale restoration plantings, we have to start now, because 15 years to create a forest, a tropical forest, is a very big challenge. And I work in a subject, and I know that not only planting is necessary. Sometimes you have to manage through the forest while it gets full forest, let's say. So I would like to have your opinion in this subject. How urgent is this? How is it possible? You still hopeful with this this idea that forests will take at least 15 years to become something?
Yes, we have to, as I said, we have to get to zero deforestation, degradation. The biggest challenge, fires. As you know, 2024, Brazil continued reducing deforestation in the Amazon, continued reducing the Atlantic rainforest. For the first time, reduced in Cerrado, tropical savanna. So, yes, but still, fires, I don't have good answers to that, but, please, you have to, wildfire management. I mean, please, after in this meeting, please advance on that. We have to see that. But also, I fully agree with you. Forest restoration has to have a large scale immediately. One of the things would be really to educate people. For instance, if we start giving educating children educating university students. Let's, I've been doing that for many years. Let's plant some new trees. Give scale. We have tens of millions of students. So if we start giving scale, so the forest restoration will reach the important scale, but we have to give scale. But also, for instance, currently the current prices of carbon markets in the Amazon, I'm sorry I don't know much about the forest restoration here in the Atlantic rainforest, but I know a lot about the Amazon. Now in the Amazon, people doing forest restoration, they are getting up to $50 per credit. Credit is 1 ton. And I know very well the Amazon forest. The Amazon forest, after 4 years, it's removing 11 to 18 tons of carbon dioxide per year. So this 11 to 18 credits. Now $50. So I'm just saying ecosystem service that would make a lot of sense economically as well. And unfortunately, COP16 in Cali, Colombia, did not create the biodiversity fund. I was there. When we got there, a lot of people there, including myself, were only talking about biodiversity fund should be $200 billion, $200 billion a year. But unfortunately, at the last 2 days, countries were talking about $20 billion a year, but then they did not agree. But also, biodiversity eventually will become also important ecosystem service. And I mentioned a third one. Well, I think, the agricultural sector, mostly in the tropical savanna, Cerrado, southern Brazil, a little bit here, should pay for the flying rivers. The rainfall depends on the Amazon forest. So that should be a third ecosystem service. So I would say I want to be optimistic but you're right, we have to give tremendous large scale to forest restoration. Yesterday we have to do it. But anyway, I'm just saying we have to work on that. I think most Brazilians want. If you ask people, they want. So let's do it.
Thank you, everybody. And thank you, Professor Carlos Nobre, for your lecture. Well, in a nutshell, we should make the climate great again, right? Because America was not that great to begin with. Now, I'm pleased to introduce Professor Ibril Izquierdo, one of the technical coordinators of the SILVANUS project. He's chair of Multimedia and Computer Vision and head of the Multimedia and Vision Group in the School of Electronic Engineering and Computer Science in Queen Mary, University of London. The talk is entitled The H2020 Project SILVANUS, Introduction, International Dimension, and Potential Impact. Please give a warm welcoming to Professor Ibril Izquierdo as he comes to the stage. Applause, people. Oh, thank you.
Thank you. Good afternoon, I think. It's already 12:30, right? Good afternoon, everybody. I would like to start by saying thanks to the local organizers of this event, Rogerio, Nelson, I haven't seen Nelson, I don't know if he's around, and the local team for inviting us and also for the organization of the event. On behalf of the SILVANUS Consortium, I am going to talk a bit about this consortium and project today. On its behalf, I am pretty pleased to be here and to have this opportunity to introduce to you, to present to you the SILVANUS project. The presentation is going to be high level. It's not going into technical details. And the reason is that we have 2 more pretty large time slots, one on Wednesday and the other one on Thursday, in which we are going to go into the technical details, so you will have the opportunity to come see, listen to the presenters technical level and also interact with them, ask questions. So this presentation is introductory and mostly what it's about. As the chairman of the session said, My name is Raúl Izquierdo. Here, I was presented as a professor of the University of London, which is my second hat. But here I am representing SME based in Berlin, in Germany, where I also live. Is the Benacar Tree Leaf SME. We are the technical coordinators of the project. What struck me when, should I, how I move this one here? Just, that's how it goes. That way? Yep, okay. The thing that struck me the most when coming here to, from the airport, just from the airport to the hotel, and I had the opportunity also to go around yesterday, was the vibrant and vast vegetation that you see here compared with the place where I am coming from. These pictures, I took these pictures yesterday, here, right? So just to see, and we are in a big city, in the city of Rio. This is a city, so just to see how this green is painting the whole city, even the pretty populated streets. If you go around, you can see all this. And this is very important. It's also probably one of the most important features of Brazil, what we know Brazil for. You may agree with me that the environmental assets of this country are probably second to none, and probably one of the main gifts given by nature to the world. Unfortunately, and it's good that we have the presentation before about the problems we are having. This is what you see nowadays. This is what is happening. These are not pictures captured by me yesterday. These are pictures from the internet on forest fires happening worldwide. And this is what is happening nowadays. And that's the reason we have this project, the SILVANUS project. I am going to talk a bit about the background, where is this coming from, and what it's about, starting with a quick reason for that. The SILVANUS project comes out of a call from the EU that was looking at the problem, and this problem is, of course, global and critical. Here is a short summary of what we are seeing in the European context. So most of the things that I'm going to present here in this first part relate to Europe. You have seen the Brazilian perspective. I'm going to be here a bit pessimistic also what is happening in Europe. So in 2023, there was a sharp increase in the burned areas across Europe, most of them affecting the traditional areas where wildfires happen, which are the south of Europe, the Mediterranean area, Greece, Italy, Spain, and so forth. But now we are seeing that more and more also happening in the north. So it's spreading, and I'm going to show you in the next slide what we can see from the last year, so that you can get a sense of how the problem is becoming more and more acute and, yeah, almost impossible. So here you can see, for instance, small, if you consider 100 hectares small areas of burned forest, almost everywhere in the continent, almost everywhere in the continent, even in the far northern regions, Finland, Norway, and so forth. But you can see also pretty large wildfires, up to 5,000 hectares happening as far north as Scotland, as you can see there. So it's not anymore the traditional belt of Mediterranean countries where this is happening, where we have seen that for many years, but it's the fact that this is increasing in these countries and is spreading north. So it's a pretty bad state. So 2024, February 24 was the warmest recorded month in Europe, and it was the 9th in a consecutive row. This meaning that almost the whole year was, every month in average was the warmest in history. 2025, we have seen February was already the warmest. This means even warmer than the year before. So things in Europe don't look better than here in Brazil, looking at what Professor Nobre was presenting before. So this is the context, and this was the challenge that is known for a long time. And back in year 2000, the EU, in the context of the funding programs for research and development, what is called the Horizon 2020, was called because now we have a new program which is Horizon Europe. In the context of the Horizon 2020 projects, issue a call, also in the context of something more bigger that probably is going to be presented here on Wednesday, which is called the Green Deal, a call for project proposals addressing wildfire management. And that is where we started, together with few other partners of the consortium, brainstorming and creating a proposal submission in response to that call. So in the second semester of 2020, we spent a lot of time writing the proposal and building the consortium for this project. The submission was done in 2021, and by mid of 2021, we have the results. Usually in this process, the EU takes some 3-4 months evaluating all the submissions, and with a panel of experts, they select the best proposals, and these proposals become projects, and they are funded. So we were very glad to see that our proposal succeeded, and on the 1st of October 2021, the project started. The consortium in this proposal is a very large, vast consortium of almost 50 partners. Most of them from Europe, so we are covering almost every single European country, but beyond Europe, we have also 3 international partners, and the reason we added these international partners to this project is because the problem, as you know, is not a European problem, it's not a Brazilian problem, it's a global problem. So what is happening here is happening there, and it's happening also in Australia and Indonesia. And so we invited 3 partners, one from Australia, the other from Indonesia. I think we have representation here from the Indonesian partners. The Australian partners could not come, and the other is the partner here from Brazil. In addition to that, as I showed before, many large industrial players like Thales, Atos, Fincons Group, and so on. Many SMEs, small companies, including our, and stakeholders, people that are on the front of the usage of this technology, firefighters, fire corps, and so on. So we have here representation from at least 2 European Firefighters Association involved. I know PU is here. I know also our Czech firefighters are also here with us. I think we have also representation here from the Brazilian. It looks like firefighting, or I am wrong. Okay, right. So we have also, of course, university, academic institutions involved, and many, many others. So the project, as I say, was funded in the context of the Horizon 2020 as an innovation action. Innovation action is one of the many instruments of the EU funding. It's one of the different instruments, probably the most popular of them. The time frame, 42 months, starting in October 2021 and finishing just in few weeks. So the project will be finishing at the end of the next month. The total cost of the project, a bit more than 24 million euros, and the contribution from the EU towards that funding is just about 20 million euros. The planned effort over 3,400 person months. That looks like a lot, but looking at the dimension of the problem, the need for a very diverse set of skills and contributions, this is not much. A total of 15 European countries participating and 3 international countries. Okay, I'm going to show to you again quick and high level, the vision, what we are doing, what we have been doing, and what we have, what we are or can show for all the money that was made available for the development of what this platform that we call the SILVANUS platform. So the original vision, which by now it should be reality because we are finishing the problem, was to develop an integrated technology platform with innovative toolkits that provide decision-making support. These are tools, technological tools based on many areas of science and technology, but mostly ICT, from AI technology to communication, transmission, and so on. And to enable or to provide these tools to the users on the ground to enable them to achieve a better wildfire management. And in addition to that, enhancing the cooperation, the interaction with the human factors, with the people. The mission was to create this synergetic alliance because in most of the conference that we have attended or we know, you have either the technological part presenting technological solutions isolated from what is really happening in the ground. And other conferences, you have the users, the people that have to go there and fight the fires, discussing how to best do that, but there is very, very little on combining feeding back to the technology from the users and making sure that everything is sort of integrated in a single platform. And of course, all the environmental forces that are at work here in the context of this huge global problematic. So in a nutshell, at technical level, so we are trying to not only cover these different players, the different technology users, environment, but also the different stages of the problem. So what we call phase A, phase B, and phase C. The phase A is prevention, is enable or facilitating to be prepared for the problem, to be prepared and to be aware of what is causing the problem, educating people, making sure that everybody knows that if you go to the forest, you shouldn't be smoking or you shouldn't be behaving in a way that endangered the forest and cause fires. So this is a very important phase. It's the phase that we call phase A, preparing before any event happens. The second phase, phase B, is the phase dealing with the response. If something happens, so how we respond, and here technology is very important because what we want to do is to make sure that technological developments are there for the people to help the people fighting, combating these forest fires. And the last phase is after the event. What we do to make good again what was destroyed by the fire. In this particular case, for instance, what the speaker before was talking about reforestation, how we can regenerate again, perhaps in a more robust way, the natural environment. So these three phases are important in the context of the development of the platform that we have been working on here in this project. Just to show you the complexity of the framework, the platform that we are developing here, we are dealing here with huge amounts of data that need to be assessed, mined, transmitted. We are dealing here with scientific innovation at the level of ICT technology, again, developing new technologies, using all the state of the art, what we know to bring better tools, better weapons to the fighters to combat the fires. And also communication and the deployment at the edge of the network, IoT devices, and so on. Again, we are going to have on Wednesday a 2-hour slot in which this is going to be presented in much more technical detail. So I hope that you will have the time to come also to that slot, and then we can have a more informed discussion at technical level. So within the platform is not only this huge framework, and you can imagine here we have 50 partners from different countries, from different institutions with their own technical developments, their own sort of platforms, and we are trying to put them together into a single one. So it's a sort of patchwork. And in that context, what we are trying to develop here is a sort of proof of concept. It's not a commercial viable product. However, in that context, we have also partners or subsets of partners in the consortium developing what we call user products. These are products, smaller products that are more close to commercialization, are more close to what is going or can be used in a real situation. I believe we will have the opportunity also to present here a couple of these user products. Many of them have been developed within the project, but we don't have all the representative of the user products here attending the meeting. For that reason, we may have the opportunity to present some of them and not all of them. Okay, this slide here, looking at the rings of protection developed or considered in the context of the project, a first line of defense, second, third, and fourth line of defense. You can see here how we also intend to approach the problem at different levels with different lines of defense. During the course of the project, 3.5 years, we have several pilots in different countries, starting from Italy, in the Italian forest, in Greece, in Slovakia, in the Czech Republic, and many others, France, Portugal, and so on. These pilots enable us to gather feedback from the users and use this feedback to improve the technology. Also, more importantly, to test the technology developed in these pilots. So after that, starting in the summer last year, we have the demonstration of what we call this integrated management. Sorry, can you help me? What IFM is? Integrated firework management, or model? Well, something. Integrated fire management. Thank you, George. I recognize your voice. Always helpful. Integrated fire management framework, a demonstration. So we started in the summer last year, in June in the Czech Republic, and we have several of them across different countries, Romania, Italy, and all these happen, of course, in the ground. So what we do is we go there to the forest of these places. These are in the forest regions of these places, like going here in Brazil to the Amazon, or here to the Rio. Here's a national park here where there's a lot of forest. And testing the SILVANUS platform, Portugal, France, Slovakia, and concluding now with the meeting that we have here in Brazil. So a couple of slides here showing you what is done in one of these integrated fire management platform. This is in Greece, I guess. I see Greek there, so it should be in Greece. That's Slovakia. Why is Greek? So I took it from the wrong. Okay, I took it from the wrong partner side. Anyway, there is in Slovakia. This year is for sure in Portugal. That was the site where we went. It looks Portuguese. This year, Slovakia again. Okay. Slovakia is a core partner, and many others. There are many others. I took just random few pictures from the repository. I know. This is the last slide. This is not a demonstration or pilot. It's just to show you the people participating in this project. In one of the meetings that we had in Athens, that was 2 years ago, I guess. So you can see some of the faces that are here also there. That's in a on the front of a beautiful building in the beautiful city of Athens. I guess that's from my side. What else we have here? Yeah, obrigado. Happy to answer any question if you have any.
Professor, do we have any questions from the audience, perhaps? Do you have any drones that can carry like 20 or 30 liters of water that can stop a fire more immediately? Son.
You are going to help me. This is a firefighter.
Hello, everyone. My name is Marek Gaspar. I'm a member of Fire Rescue Service of Czech Republic. Yes, drones are a good tool, a very helpful tool, but not just only for firefighting, but also for logistic, and especially for survey, most usual, because drones are very fragile in the wind torrent, and it's not always easy to use them in these conditions, especially during the firefighters that are really strong wind torrents above the affected area. It's not always easy to reach the right place to drop the water.
Marek, I think the question was more on big drones able to carry big amounts
but
of water.
But still, it's pretty same. What I wanted to say is much more effective in this way are helicopters.
It takes too long, it's too far.
Just, you mean to transport the water from the water sources to front line, you mean? What do you mean? For extinguishing, direct extinguishing?
The point is, so sometimes the fire starts at a very high place, so it takes a very long time for the fire squad to get there. So if he had a drone filled with water, then perhaps he could, attack the fire more rapidly.
Definitely, but in contradiction to this, so once the fire starts somewhere unreachable location, we know, especially in the mountains, it spreads very fast. So we can't expect to be stand still on the one place. And it's about the moving, about the winds, and so on, about the weather conditions, the place. I'm still most important, I think, drones in this time, for the time being, don't possess the capabilities to bring enough water at the scene of fire for the time being. Maybe next future, yes, we know about the big drones. We know about the capabilities, and this segment is evolving very fast recently. We know why. there is a war in Ukraine, for example, and it's a very great, a very big impulse into drone technology in various segments of using. So.
I think one important aspect here, and this is considered in the project, is the fact that we are integrating also phase A here, which is making sure that we are also prepared. And I think this preparedness, as we call it, is important here. From my experience and coming from an area that has been also affected for the first time in history by wildfires, which is the area surrounding the city of Berlin, where I live, Brandenburg. We had the first fire ever, forest fire ever 2 years ago, and was a bad one. And what is happening now is that we are trying to develop infrastructure in the site that enable a quick combat of the fire if it happens. Basically, we are putting there communication infrastructure, water fountains, and this type of things that can be tapped on the place and very, very quickly. I think that's important. I am aware of the fact that this is a different scale. I'm talking here about an area that is, I don't know, as big as 1/20 of Brazil. So if we're talking about the Amazon, it's a different scale, and then the challenges are completely different. But still, it's important to start thinking about that approach. So being prepared, not waiting that the fire happens, but having something on the ground already there available to combat the fire if it happens, especially in areas which are very important for the forest areas, forest areas which are critical for the whole ecosystem.
Just one last comment to the drones. During the, for example, during the parallel demonstration in Czech Republic, we were more focused on synergies between different particular user products to mean combine drones with other technologies. There is really, these fields provides us pretty much opportunities for future to cooperate, to put into one solution many technologies and utilize them. So we used drones for example, connectivity at the scene of accident, for recognition, for transportation, for logistics, and so on and so on. So, you know, it's always about the money. Drones, big drones, are not easy, are not cheap. So we, as a firefighter, decide to buy drone. It must be multi-purpose equipment, not just only for one particular thing, but for logistics, for reconnaissance, for firefighting, for example, and so on and so on. That's all. Thanks.
Last word, answering your question, you can see the integrative nature of this project. So we are really here working not only, I am an ICT person, I am professor of ICT, electronic engineering, AI, so I have very little in common with the firefighters. But we have the firefighters out there that are communicating with us. We have also the communities that help us to make or to spread awareness. We have people dealing with ethical issues, people dealing with legal issues, all that. So we will have also a panel on the last day in which we are going to cover all these different aspects of the project. So that's important.
Vou ficar aqui do seu lado. Boa tarde a todos e todas.
Good afternoon, ladies and gentlemen.
Me chamo Hélio Vanderlei, sou secretário de Meio Ambiente e Clima da cidade de Paracambi, uma cidade da região metropolitana que tem 50 mil habitantes.
His name is Hélio, and he works with the Secretary of Environment of Paracambi, which is a city in the metropolitan region of Rio with 50,000 inhabitants.
Estou aqui com a equipe do Meio Ambiente, subsecretário de Clima, superintendente de Clima, diretores, para ouvir e entender um pouco como o Silvano é importante para a nossa gestão municipal.
He's here with his team in the Paracambi administration to understand how Silvano is important for their administration.
É importante deixar claro, no meu ponto de vista, que as políticas públicas municipais são estratégicas para a redução das queimadas, dos pontos de calor nas diversas cidades que estão aqui presentes ou no mundo?
In his point of view, the municipal jurisdictions have a very important role to play in the climate emergency that we now live in, both here in Brazil and in the world.
Me parece que estamos discutindo qual é a capacidade do município de fazer planejamento, gestão, investimentos, metas e resultados.
It seems we're discussing how the municipality can have the capacity of managing funds to combat climate change.
O que, na verdade, é uma grande dificuldade dos gestores municipais do Brasil terem a oportunidade de construir plataforma de gestão, seja para manter as florestas em pé, seja para ampliar a área de floresta com unidade de conservação, seja recuperar as áreas degradadas com restauração florestal, seja ter equipe de prevenção e combate a incêndios florestais.
Wow. It seems municipalities have a very hard time.
Não tem problema. Okay.
Managing deforestation and, well, basically deforestation and reforestation.
A nossa cidade, na região metropolitana, tem um prefeito de 26 anos.
That was easy. Our city has a mayor who's 26 years old.
E ele definiu com clareza que ele queria planejamento, gestão, metas, investimentos e resultados.
He defined clearly that he wanted... Come again?
Investimentos,
investment,
metas,
targets,
resultados
results,
e, acima de tudo, preservação ambiental.
And above all, environment preservation.
Primeiro, ampliando a criação das unidades de conservação.
First, amplifying or growing the units of conservation.
Segundo, uma equipe técnica altamente qualificada para planejamento e gestão.
Second, a highly qualified technical team for managing.
Terceiro, contratação de equipe de prevenção de combate a incêndio florestal.
Three, hiring a squad to combat wildfires.
Investimento em recursos humanos e tecnologia.
Investment, human resources and technology.
Monitoramento constante das áreas queimadas e das ações efetivas de combate.
Constant monitoring of...
Monitoramento das áreas que sofreram queimadas e teve atuação da equipe de prevenção.
Constant monitoring of burned areas which had the action of preservation squads.
O que eu quero dizer com isso, para encerrar?
What I mean by that is
que nós, que trabalhamos na ponta, nos municípios, somos os responsáveis pela gestão e a governança.
That we who work in the municipalities are, in the end, responsible for managing and government.
Que podemos ter diversas tecnologias, mas se não tivermos o homem treinado, qualificado, equipado e em condições de fazer a prevenção com educação ambiental climática e com as ações efetivas de combate, não vamos resolver o problema.
That we can have the technology, but if we don't have the enough qualified and technologically trained manpower, we won't have anything.
Okay?
Training.
Yeah,
in that context, thank you very much. In that context, I think training is also important, and it's also one aspect that we are addressing or in the project. So I have a quick question for him, because he mentioned almost everything that we are doing. He mentioned almost everything what we are doing in Silvanus. My question is, what are he mentioned burn areas, fires, all the things, and what they are doing in the context of putting together the human assets and ICT technologies. The question is, what is the experience? Do you had in the past fires? What is the state now of reforestation? What can we learn from these experiences?
Você já teve incêndio lá? Como é que foi? Como é que vocês estão fazendo reflorestamento? O que a gente pode aprender com
No ano 2024, a cidade teve 364 pontos, aproximadamente, 399 pontos de queimadas.
So last year they had 399 points of fires in the city.
E não existia nenhuma estrutura, nem infraestrutura para dar suporte ao
Sorry,
combate.
these fires in the city are wildfires or normal fires in the city?
Wildfires or
What?
normal fires? Incêndio florestal, wildfire. Incêndio florestal?
Sim.
Wildfires.
Não tinha estrutura, não
There
tinha
was no
equipe
structure, no team,
e não tinha investimento.
and there was no investment.
O que muda?
What changes? The election.
Planejamento, equipe treinada, qualificada.
Planning and a trained and qualified team.
Então, nós já temos uma equipe pré-fogo treinada e já em atividade.
So we have now a team that's trained and currently working.
Coordenada por uma mulher.
Coordinated by a woman.
Né? Temos equipamentos para fazer o enfrentamento diário.
We have equipment to do everyday fighting.
Em janeiro e fevereiro tivemos seis combates a incêndios.
So in January and February, we've had 6 combats.
6 pontos de fogo.
6 points of fire, and therefore 6 firefights.
E estamos montando nosso banco de informações, banco de dados,
So we have now a database
para no final do ano ter uma visão bem clara de quantas cicatrizes tivemos, quantas áreas combatemos e qual comparar com o ano anterior.
so that by year end we have a clear understanding of the scars that are left and how we can prepare for the future.
E para finalizar, dos 30 profissionais técnicos que nós temos, dos 30, 70% é mulheres. Por isso está dando certo.
So out of 30 people that they have working with them, 70% are women, and that's why it's working out.
For the EU funding, this dimension is very, very important. We call the gender dimension, and it's always one of the assessment measures of the proposal. So very important. Thank you. Well done.
So thank you very much for being here with us. We have more tomorrow and a couple of days afterwards. So we invite you all to be here and to join us for the next talks and discussions. Thank you very much for having us, and thank you. That's it. Good day.